In this problem, I'm going to make a box to wrap a birthday present. I have a poster board that I start with, and it is 10 inches longer than it is wide. I cut squares with sides 2 inches from the corners so that I can fold the flaps upward to form an open box. If the volume of the box is 528 inches cubed, what were the original dimensions of the piece of cardboard? So let's draw this out. First of all, I'm going to pull in a picture I drew from the notes. And let's look at this picture. This is the poster board. I wanted to create a box out of that poster board, so I cut these flaps out of it, and the sides of these flaps are 2 inches each. So once I cut those out, I could fold up the flaps and form a three-dimensional box. Now, the width of this side is W. The length of the poster board is 10 inches longer than it is wide, so it's W plus 10. This distance in here between the flaps, or between the cutouts, represents the width of the box that I create. And we'll use a little w to talk about the width of the box. The big W talks about the width of the poster board. So if you take the width of the poster board and you cut away these 2 inches and you cut away 2 more inches, then this is the equation that represents the little width here is the big width here. Then you take away those 2 inches and you take away those 2 inches. In other words, it's the big width minus 4. And similarly, the length between here and here, or the length of the box that I create, is going to be the length of the poster board minus these 2 inches minus these 2 inches. And so the length is going to be, if we substitute in this, W minus 10 for length, and then combine these to get minus 4, we get that this little length here is going to be this big width plus 6. So now we have an equation for little w and little length, and we know that the height is 2. The volume of a box is volume equals length times width times height. And we know that our length of our box is going to be, if we look over here, is the big length minus 2, which works out to be W plus 6. And then our width, our little w in here, we found is our big W minus 2, or W minus 4. And our height is 2 inches. So we know that our volume is 528 cubic inches, so we can use this equation to write that 528 inches, cubic inches, is length times width times height. I'll put the 2 first. W plus 6, W minus 4. Okay, let's go ahead and put everything on, switch the sides of the equation so we get our w's on the left. So we'll just rewrite the equation this way, and then divide both sides by 2. So we have w plus 6 times w minus 4 equals 264. Let's FOIL the left and also subtract 264 from both sides. So we get w squared minus 4w, and then plus 6w gives us plus 2w minus 24 minus 264 equals 0. Simplifying that, we get w squared plus 2w minus 288 equals 0. So now we can apply our quadratic formula to find w. W equals negative 2b plus or minus negative b plus or minus the square root of b squared minus 4ac. All of that over 2a. So we get that W equals negative 2 plus or minus the square root of 4 plus 1152 over 2, which gives us negative 2 plus or minus 34 over 2. And so that gives us either 32 over 2 or negative 18 over 2. And since it can't be a negative number, then our answer is 32 over 2 or 16. So we found that our big W is 16. That's the side of the poster board. So let's write that down. W equals 16. And check again to make sure we know what we're being asked. And we're being asked, what are the original dimensions of the cardboard? Well, we found W is 16. So that means that the length is W plus 10. So the length is going to be 26. And let's do a quick check of this. We checked this by plugging into this equation here, where we have 528 equals 2 times W plus 6. Well, W is 16, so that's 22. W minus 4, which is 12. So that gives us that 528 is equal to 528, so it checks. Here is a launch problem. A ball is thrown up in the air from the ground by Grayson. Its distance from the ground in t seconds is given by the equation s of t, and that means distance, equals negative 16t squared plus 128t. You are to find the times that the ball will be 110 feet from the ground. So let's picture what we're doing. Grayson's launching this ball, and we want to know, when will it be 110 feet from the ground? This could have one of two situations. One is that this is 110 feet, somewhere like this. And so there would be 2 times where it would cross 110 feet. The other situation is that this could be 110 feet, in which case there will only be one time because it's the peak. Okay, so let's check this out. We're going to substitute in 110 for the distance, and then we're going to solve for the time. So we have that 110 equals negative 16t squared plus 128t. Let's add 16t squared and subtract 128t from both sides. And here's what we are left with. 16t squared minus 128t plus 110 equals 0. To solve this, first I'm going to take out the common factor of 2. So I divide everything by 2, and I get 8t squared minus 64t plus 55 equals 0. Now I'm going to apply the quadratic formula to find t, which is negative b is negative 64, plus or minus the square root of b squared minus 4ac, all of that over 2a. So that gives us 64 plus or minus the square root of 4096 minus 1760 over 16, which is 64 plus or minus 48.33 over 16, which is going to work out to be 7.02 and 0.98 seconds. So when the ball is rising in almost a second, 0.98 seconds, it crosses 110 feet and keeps rising. And then as it falls, when it gets to 7.02 seconds, it crosses that 110 foot mark again. So you can check your work by plugging in 98.98 seconds and also 7.02 seconds into your equation and making sure you get a true statement. Here is a supply and demand question. The local bakery found that the daily demand for pumpkin cream cheese muffins is 22,400 divided by the price of a muffin in cents. The daily supply is 6 times the price of the muffin minus 200. And you are to find when the supply and demand are equal. So you are to find when 6p minus 200 equals 22,400 over p. So let's multiply the both sides by p so that we can eliminate the p in the denominator here. And we get 6p squared minus 200p equals 22,400. And let's divide everything by 2, and we get 3p squared minus 100p equals 11,200. And bring the 11,200 over by subtracting it from both sides. And then we're setting our equation to 0 so that we can apply the quadratic formula. So p is going to equal negative b, which is negative 100, plus or minus the square root of b squared minus 4ac. All of that over 2 times a. So that's going to give us 100 plus or minus the square root of 10,000 plus 134,400 over 6, which is 100 plus or minus 380 over 6, which is either 480 over 6 or negative 280 over 6. And we can discard the negative possibility. So that tells us that P is equal to 480 over 6, which is 80 cents. So when each muffin costs 80 cents, the bakery breaks even. Again, you can check your work by plugging 80 back into your original equation, and you'll find that the equation will then be true. So this summarizes 18.4 in your textbook, and also on the exam review videos you'll find a few more applications problems. Do not plan to skip the applications problems because there are enough of them that it will cost you greatly on the exam. Good luck, and let me know if you have any questions.